So I think that we have our recording running. And first of all, I really, really do appreciate you being here. I know that as the semester moves on, it gets busy and everyone has a lot going on. We're now at the week 9, and for this week, what I have planned was for us to talk a little bit about introduction to the muscular system. So far we have looked at the bones, first bone tissue and general things, and then we looked at the individual different bones. And now we're going to move on for the next 2 weeks of talking about first of the muscle tissue, and then we'll review some of the most important bones in the body, or most important muscles in the body. I'm not gonna lie that I think that today's or this week's chapter is a little lighter. There's some key things that I want to talk about when it comes to the muscle tissue, but I really want us to make space that next week we will cover actually quite a lot of different muscles. And when we're covering those different muscles of the body, really there's no great way for me to make it interesting or exciting. A lot of it is just memorization, so a lot of that will be you looking at individual muscles. I have a bunch of materials, handouts and others that hopefully will help with that process, but really, to be quite honest, I think that if you want to make a start, work ahead on the next week's material. If you get through this week's material real quickly, that is encouraged, but not required. Really quickly about the plan that I have for today. Like I said, I want to mention just quickly how much I appreciate you being part of this class. And then I want to explain my own situation real quickly before we focus on the main goal of the day, which is to kind of give you a nutshell, condensed version of the chapter material for chapter 11. If we do have time, we'll look at the homework assignments, but I do have another meeting that's pushing on my back at the full hour, so I'm probably going to try to go through things quickly, and depending on where we are at the point when we start to approach the full hour, we'll have a look if we have time for the homework or not to look at that. So on that note, the very first and most important thing that I wanted to share with you is that I definitely do see the great work that you're putting in. I see the great grades. I see the great constant effort that you're putting in. So please know that that is being appreciated, and that is so important on these online classes. I think on these online classes, really the secret to success is to just collect those little points throughout the semester. It is really just being steady and focused on getting the work in what gets you a great grade in the online class. On that note, I do want to appreciate, and I want to make it known that you appreciate that I appreciate it. The effort that I see that you're putting in. There's a lot of measures that get communicated for us as your instructors on online classes, anything from the amount of time you spend on assignments, the grades you get, and so on. So I see the great effort going in, and I'm so grateful to have you in this class. So that's the first and most important thing that I wanted to share. At the same time, in only way how I know to teach is to be a totally transparent. In the same spirit, I have to admit that since I am going to the school myself, I'm working on my doctorate as well as working here. I realize that this time of the semester is the busy time. This is the time when we all have essays due. We have a lot of big things going on. Not only that, but also professionally in my job, I do have quite a lot of demands going on now for my time, like the fact that I have to keep this session today short. So I might be taking a little longer than I normally take to respond. Normally, I aim to respond to any messages that I get within 24 hours or at least 48 hours. But at the moment, just because of the workload, there is a chance that I might take a little longer, but I will get back to you. Same goes for the grading. I normally make a commitment to my students that all the grades for assignments uh, are published within at least 1 week of the due date. And I think I'm doing really well on that at the moment. But there is a slight chance that I might need a little longer just to get through all of the things that need to be done. So bear with me. I anticipate that by the end of this week, I should get back to the normal rhythm of the things. But if I'm taking longer than normal, and if you're needing an urgent answer, do not hesitate to message me and remind me. You don't have to put in more effort, just send the same message again, and I'll try to respond as soon as I can. This semester, we've been spending a little bit of time on kind of doing little self-care check-ins, if you wish to call those that. And since it's been kind of hard for us all to meet at the same time, so I've been using a book called Inward from Pueblo, Asian philosopher, and rather than asking students to pick a random page from that, I just picked one for today, and I saw that the thought of the day that was shared on that book for us for today goes along the lines that I gathered my habits and started releasing the ones that can never lead me to lasting freedom and joy. And I really think what that tells us is that habits of how we operate is what dictates how happy and how successful we are. So I encourage you to develop those habits, whatever works for you, whether it's on this online class, finding techniques of learning that work for you, or whether it's in other aspects of the life. But focus on what works for you. Not everyone has to do everything. In these classes, as a teacher, I always try to give a broad spectrum of many different things that serve many different learning styles. You don't have to do anything that doesn't work for you, but what works for you, capitalize on that. So I think that that's the take-home message from there. For this week, like I said, I have chapter 11 that I'm hoping us to work on. I have two assignments for it. I have the quiz and the practice anatomy for that chapter, because it is really kind of a generics chapter. It's kind of a shorter chapter. I didn't want to load this week with too much work. Next week, again, we'll get back to things like doing food for thoughts assignments. And we're getting a little bit more of those simulations that I was asking feedback on and so on. So this week's workload is a little lighter, but keep in mind that if you get through it real quick, and you're looking what to do next, nothing prevents you from moving to the next week's chapter and kind of getting a head start of getting your head around to that. But you will be able to do everything next week. There will be enough time for all of that. But that's just something that I want to put out there as an option. So the quiz and anatomy practice, those are familiar assignment types for us. We complete them on the Canvas. So the publisher's learning platform, you should be automatically linked into there once you click at that activity on our course. So now to the main point that I had kind of really planned for today, and what I wanted us to spend time is to just kind of orientate ourselves and get a general idea of the muscle tissues. And what we end up finding is that nearly half of your body mass is made by the muscular system. And how muscular system really works, if we go back to what we remember from our introductory biology classes like BIO201, we see that muscles transform that chemical energy. And you remember the chemical energy on a cellular level was stored as ATP, and muscles convert this chemical energy into mechanical energy, so movement. That's really what muscles do. That's the big purpose of the muscles. So that's why we find within muscles a lot of mitochondria. Mitochondria converted the sugars, for example, into ATP that can then be used to generate movements. In order to think about what we need to look at when we're talking about the muscles and what we're focusing on this week's material. We'll look at the different types of muscle that we have. We look at the characteristics of muscle tissue, and we also look at the muscle functions. Those types of muscle, we will expand on that topic a little later when we get to the actual next week's material, but I want to keep it on a very, very broad scale today. So to get us started, the term muscle comes from Latin word for a little mouse. And there was a belief back in the day, early anatomists and physiologists thought, because they saw these movements in the body, that maybe there were little creatures that were creating those movements. But obviously we know that that's not really the case. It is the muscle tissue itself that's contracting. But whenever we're talking about muscle chapter and chapters that involved with muscular system, we might see words and prefixes such as myo being used, so like myofibril or mice. That is also commonly used. We see sometimes sacro also being used when we're talking about muscles such as sacroiliac. So those sort of words keep coming up. So I just wanted to make sure that if any of those terms come up, that doesn't throw you off. But we're talking of the same things. We're talking of the muscles of the body. And rather than drawing these, which is what I normally do, just in the interest of time, I already sketched these 3 different muscle types that we have in the body. So you remember skeletal muscles, where if we looked at a single cell of a skeletal muscle, they were kind of cylindrical in shape, and they had these striations running through the muscle cell for the entire distance. One thing that we see in the skeletal muscles is that skeletal muscles have multiple nuclei. And these multiple nuclei are typically located at the edges of the muscle cell. And that sometimes confuses students when they're like, how can a cell have multiple nuclei? I thought that there was only one nucleus per cell. This is because how skeletal muscles form by fusing together multiple early cells that we find this arrangement. I think the big thing to take away from the skeletal muscles, which is going to be the focus of ours, is that these are voluntary muscles. So these are muscles that are under your voluntary control. You choose when they contract and when they don't contract, at least for the most cases. There are some exceptions. And these are all the large muscles in our body that we see when we talk about the muscular system and the muscles that generate big, great movements in our body. We did also have cardiac muscle cells, and cardiac muscle cells were typically characterized by being branched cells. And at the end of these branches, we had intercalated discs. These branches and intercalated discs facilitated easy passage of messages and materials from one cell to another. And that was really important for us for ensuring that the muscles are synchronized and contract at the same time. You will end up seeing that you typically have one central nucleus and multiple striations in these cardiac muscle cells. Cardiac muscle cells are involuntary, so they contract without you having to think about it. It happens automatically, and they are found within the heart. And finally, we had smooth muscle cells. Smooth muscle cells were just basically these blobs that did not have striations, unlike skeletal and cardiac muscle cells. They don't have striations. They have one central nucleus, and they really are found around your intestines, around the blood vessels, regulating, for example, vessel diameter. And these are, again, involuntary. You don't choose when they contract and when they don't contract. So those were our 3 different muscle types that should be familiar from the introductory biology classes. Our focus will be on the skeletal muscles. And when I think about the muscles and characteristics of a muscle tissue, there's certain characteristics that we find in this tissue. In fact, these are the only body tissue with these properties that are found in all of these. So we find that muscle tissues are excitable or irritable. That means that they respond to stimuli. In addition, muscle tissue is very contractile, so they shorten, so contract when stimulated. On that note, I do want to make a point or a side notion that muscles can be still working even if they're not really changing the length. For example, I think yoga is based on this kind of stretches, or even when you're holding a heavy weight, still your muscle is working just to maintain its shape. So don't let that trip you out. In terms of extensible characteristic of muscle tissues, we end up seeing that muscles can be stretched in response to the forces. And in terms of elasticity, we see the muscles being able to recoil, return to their original resting length when the force stretching them has been removed. So these are all kind of general characteristics of muscle tissue. One thing that I wanted to highlight based on my own previous background is the importance of, when we're doing muscle training, for example, in athletics, of really following the correct technique, following correct instructions. So what we see is that really giving instruction patient to exercise that does not follow the line of the pull will be less as effective, but could also put additional stress on the muscles, damaging these. So really a good trainer will always talk about the importance of the right technique. And let's have an example of what can happen if individual has poor technique. So this is a little gruesome picture. So if you're squeamish, look away. Here we see an athlete, a famous case, where as a result of wrong technique, weight training only one set of muscles, often muscles come in pairs, and training only one of this pair of muscle groups will cause the other pair becoming overtly strong, and can even lead into muscles becoming so strong that they even break a bone. So overtrained set of muscles, for example, when we think of flexors and extensors, can damage, get so great forces that they can damage even the bones. So looking at the functions of the muscles, we have multiple functions. Movement, producing movement is an important one. So this is where we see the locomotion, manipulation of different body parts, things like walking, digestion, pumping blood. Really creating movements is important for when it comes to the muscle functions. Another thing that we end up seeing is the helping to maintain our body posture and body position. So it's even just to stay still is a lot of work. And I think that one of the things that I normally do with my students in face-to-face classes is that I ask them to stand up on one leg and just to stay on that position. You're constantly doing a lot of interaction between muscular system and nervous system, just balancing yourself. So there's a lot of things going on there. Stabilizing joints is another important function that muscles do. So skeletal system and muscular system work together. You remember joints where we had two bones coming together. A lot of the time it's important for us in our day-to-day life to stabilize these joints, and that's where the muscles step in as well. And we do see the role of muscles also in the heat production. So we see that whenever muscles are working, we're converting energy from that chemical form to physical movement. And whenever we convert forms of energy to another form, we end up seeing that causes us to also lose some energy as a byproduct, as a heat. And sometimes that can be just that we get warmer as we're exercising, we're being physically active, but sometimes it can be intentional. For example, when it's a cold weather, we get shivers. That's our muscle activity on purpose generating this heat to help us. I have a little bit of other additional functions: protecting organs, forming valves, controlling pupil size, goosebumps. We already talked about those, erector pili, and so on. So muscles are much more varied than we often give them credit for as a tissue type. Let's talk about skeletal muscles in particular a little bit. In males, about 42% of the body mass is going to be skeletal muscles. In females, about 36. The difference is really due to the testosterone, the greater ability to enlarge muscle fibers in males. So we're starting to see again these interactions of systems. Endocrine system impacts muscular system. Skeletal muscle is really what we're going to be focusing on, but let's talk about skeletal muscle as an organ as well. So what we end up seeing with the skeletal muscles is that there's a lot of regulation going on. So there's nerve innervation, blood supply, draining of the blood from these sites. There's connective tissues around them. And then there's also attachment points. So a lot going on there. And let's zoom in to a skeletal muscle a little bit. So what we're seeing here, we're kind of zooming in at each level as we move on this picture to the lower right corner. We're seeing that we first of all have our epiphyseum. The epiphyseum is the most external kind of a connective tissue layer that surrounds the muscle. Then we zoom in and we see that this muscle is made of multiple bundles of muscles surrounded in perimucin. Perimucin surrounds a group of muscle fibers known as a fascicle. And even if we zoom into there, into a particular part, we see that we have our endomucin, which surrounds individual muscle fibers. So we can really look at muscles on this scale from going from larger to smaller in terms of the microscopic level. When we talk about the muscles, one thing that I think that often teachers love to focus on is the attachment points of the muscles. So muscles typically have origin and insertion, origin being usually the more proximal attachment point to the immovable, less movable part, whereas insertion is usually the more distal attachment point to the movable bone. I think a lot of textbooks spend a great amount of time when you're revising those muscles that we'll see next week for you to find the insertions and origins of muscles. I think that that's important, but anatomically, having been trained as an anatomist, I think that I do have a little bit of a different angle to this. I think that the big thing that we end up seeing is that muscles contract, and to me, really, it's just finding the attachment points. It's not even just whether you know it's whether it's an insertion or an origin. I just want you to know the attachment points. The reason why I say is that muscles work as levelers. So I think that we see that these muscles run to produce movements as they run over a joint. And what we end up seeing is that by adjusting really the length of the different parts that we have in a set of structures, we can actually amplify forces. So you know that, for example, lifting this rock alone would be very hard work, but if we use this leveler concept of a stick against the pivot point, we can actually make much more movement with lesser effort than we would otherwise in relation to that load. So you might wonder, how does this really relate to what we want to see? We see that certain muscles run long distances over these joints, and by running these long distances over these joints where they're acting on, we're able to replicate this leveler concept and generate more forces. In the interest of time, I'm just going to keep going. And when we look at the microanatomy of a muscle and the sliding filament model, we'll end up noticing that skeletal muscle fibers are these long cylindrical cells that contain multiple nuclei, as we saw earlier on. And within a single sacroleuma, that was the plasma membrane of a muscle fiber, we have then sacroplasms. This is the cytoplasm of the muscle. And there we have something that's known as a myofibril. And there's many, many myofibrils. These are kind of rod-like elements. They actually make up about 80% of the muscle's volume. So let's zoom into this structure and have a look of it a little bit more. Each myofibril contains sarcomeres, and these are kind of like the single blob between one Z disc and another Z disc. So let's focus these sarcomeres a little bit and have a look what we learn about them. When we look at this microscopic structure, this actually helps us to explain those striations that I mentioned earlier on that we saw in skeletal muscles and cardiac muscles, but not on the smooth muscles. These striations are dark and light bands. So we're seeing where the light goes through the sample easily or it does not go. So we either get the dark band, which is known as our H zone, or light band, which is made by these Z discs. So you might ask at this point that why is the sarcomere important? And it is the smallest contractile unit of a muscle fiber, so the functional unit that we have. And if we look at it in more detail, we actually see that we have something known as a sliding filament model, where the actin and myosin, which are the microscopic elements, slide past each other as muscle stretches and shrinks. So literally there is movement on a microscopic level from stretched shape to shrunken shape. I did want to show or make a point that we do see that there's also neuromuscular junctions. Nervous system is tightly connected here, so passing messages to the muscles, causing then the contraction to happen. So that's really important concept for us to be aware of. Normally in my classes, I would also talk a little bit about rigor mortis in relation to the calcium, which causes these sliding filament structures, our actin and myosin filaments, to interlock and stay still in a person who has passed away. But unfortunately, due to the YouTube, I'm going to have to be careful. I can't show you pictures. The pictures are there in the actual lecture videos if you want to see those individuals and how rigor mortis really stiffens the body after the death. I see that it's a full hour and unfortunately I'm gonna have to jump off from this meeting, so I will skip the review of the homework assignments and I will just wrap up this session here. But as always, I am available for questions, for discussions later on if you have any of those. Unfortunately, I just have to be gone for about a half an hour for another meeting. That's a college service duty. So thank you again. I hope you have a very good week, and I look forward to answering any questions. If you have any, so don't hesitate to drop them over for me. Thanks again. Bye.